In this lecture I'm looking at the solution to question 3 of the June 2010 Edexcel M1 paper. This is a question on dynamics. The question sets out from a figure 1 and a description of that saying that a small box is pushed along a floor and the floor is modelled by a horizontal plane and the box by a particle. The coefficient of friction between the box and the floor is given to us as a half. We're told that the box is pushed by a force of 100 newtons acting at an angle of 30 degrees with the floor. Given that the box moves with constant speed, find the mass of the box. Well, I've put that information onto this diagram. We have a constant speed, and therefore we can say that the horizontal forces must equate to 0 because we've got no acceleration, therefore the forces are 0. So the first thing then is to look at that idea. So with the horizontal forces we have got that 100 cosine of 30 degrees, that's the component of the 104th, must be equal to F. But we know that F is equal to mu r, and therefore we can say that 0.5, which is mu times r, is equal to 100 cosine 30 degrees. And multiplying through by 2, this means that r is equal to 200 cosine of 30. Cosine of 30 is root 3 over 2, so that gives us 100 root 3 for r. If we then resolve vertically, well, we've got r acting upwards, and then the other two forces, mg, and the other component of the 100, so this time it's 100 sine 30 degrees, are acting in a downwards direction. So r is equal to mg plus 100 sine 30. So substituting for r, 100 root 3 is equal to mg. Sine 30 is a half, so this is just plus 50. And then rearranging that to make m the subject of this, we get 100 root 3 minus 50 and divided by g, which is 9.8. So that's a little bit of calculator work, and the answer comes out to be 12.6 kilograms to 1 decimal place. Well, looking at the mark allocation then for this, there was an M1A1 mark for the resolving horizontally and saying that the forces equated to 0. A B1 mark then for getting F is a 1/2 r, so no method required there. M1 and A1 for resolving correctly in a vertical direction, and then what's called a dependent M mark. This means that as long as the method was correct up to this point, then another method mark, dm1, followed by an A mark for getting the mass correct at 12.6. So in total there are 7 marks. Well, that's the end of the solution to this question. You'll find solutions to other questions at www.furthermaths.org.uk.